Section 9.3 talks about solving quadratic equations. There are going to be a number of ways we will talk about solving these. We're going to start with some fairly straightforward equations. First, remember that the general form for a quadratic equation is y equals ax squared plus bx plus c. Quick review: yesterday we talked about the vertex of the parabola, and we found the x value to be equal to negative b over 2 times a. You would then take that value, negative b over 2a, you'd plug it back into the function, so f of negative b over 2a, and that would get you the y value for the vertex. That's one point that helps you graph a parabola, a very important point. We also talked about finding the y-intercept. And remember, the y-intercept was essentially the value of c when you plug 0 in for x. What do you get? C. So those are 2 points that help us graph the function. There are some others that we're going to talk about on the next slide. On this slide, I'm going to talk about what they call the zeros of the function. They're also called the roots of the function. Now, if you look at a graph, let's say this is my graph. The zero, put that over there a little bit. The zeros, or roots of the function, will be right here and right here. It's where the graph crosses, the x-axis. Another way to think about it is the x value when y equals 0. These are very important, and again, they're called zeros and they're also called roots. So let's look at a simple example and find that. Let's say I have a function, an example here, x squared minus 1 equals 0. So I want to find out basically when this function equals 0. So I've gotten it to this point. Now I'm going to add 1 to both sides. So I get x squared equals 1. Now I'm going to take the square root of x squared, the square root of 1, and I get x equals plus or minus 1. What that tells me is that the curve will go through the x-axis at positive 1 and at negative 1. I also know, well, let's go ahead and identify a, b, and c. A equals 1, b equals 0, because there's no x term, c equals negative 1. So I know the y-intercept is going to be at negative 1, and I can go ahead and find the vertex. Remember, the vertex is simply negative b over 2a, and b is 0, so it really doesn't matter what's down here. So the x value of the vertex is 0, so look, oh, it must be at 0, negative 1, so my curve will look like that. Let's look at another example. Let's say I have 3x squared minus 75 equals 0. All right, I set the equation equal to 0. Now I go about isolating x. I'm going to add 75 to both sides. So I get 3x squared equals 75. Divide each side by 3. X squared equals 25. Now I'm going to take the square root of both sides. and I get x equals plus or minus 5. So those are my roots, or x, they're also called the x-intercepts. All right, let's see what else we can find. Well, let's identify A, B, and C. A is 3, B is 0, C is negative 75. So my vertex is going to be at negative B over 2A. So I have 0 over 2 times 3 equals 0. So the x value of my vertex is 0. Now I plug in 0 to solve for the y value of the vertex. And I get y equals negative 75. So my vertex is going to be at 0, negative 75. My two intercepts are plus or minus 5. So I can go ahead and graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm just going to call that negative 75. So put a point there, put a point there. That's my vertex. I also know that it's smiling, it's shaped up because A is positive, and I can go ahead and graph it like, there we go. One last example. Let's say I have 5x squared minus 20 equals 0. I'm going to start by adding 20 to both sides. So I get 5x squared equals 20. Then I divide both sides by 5. Again, I'm trying to isolate my x. I take the square root. So here are my x-intercepts. Now negative b over 2a. A was 5. B was 0. C is negative 20. So negative b over 2a is 0 over 2 times negative 5 equals 0. So the x-coordinate of my vertex is 0. I plug 0 into the equation, solving for y. 5 times 0 minus 20 equals y. So the y-coordinate of my vertex is negative 20. It's going to be shaped up. 1, 2, 1, 2. Call that negative 20. There's my x and y intercept. There's my vertex. And there we go. So there you go. You should have plenty of information there to go ahead and do your homework.